Hello wonderful person, this is Anton, and today we're going to be talking about one of the more mysterious objects very close to the solar system. This is actually one of the closest objects to us, the so-called brown dwarf binary system known as Luhman 16. Let's discover what these scientists have recently found here, and welcome to What the Math. So this right here is what's known as a brown dwarf. This is a mysterious object that we don't actually even know how to technically classify. It's not really a planet, it's not really a star, it's basically something in between. So, a brown dwarf. If we were to start right here around planet Earth, and if we were to start looking around the night skies, unfortunately none of these brown dwarfs, even the closest ones to us, would be visible to us. Only the stars produce enough light to actually be seen, but for the most part, most of the brown dwarfs, even the ones that are extremely near us, were only discovered a few years ago by using a telescope that was able to see in the infrared light, because the majority of light produced by these beautiful objects is infrared. Although in some cases they also produce a little bit of visible light, and in some cases they produce radio waves, and even a little bit of X-ray radiation, but in very rare cases. But even though we can definitely see the nearest star to us, Alpha Centauri, we cannot see the nearest brown dwarf, which is only a little bit farther away. I'm going to show you where it's sort of located, it's somewhere over there, but it's basically going to be invisible simply because it's barely producing any light at all. And there are actually two different brown dwarfs here. They're known as Luhman 16, and they're actually named after the scientists who discovered them back in the days, and not so long ago actually, back in 2013, and here you can kind of start seeing them orbiting around one another. A single orbit here takes about 27 years, and the distance between them is equivalent to about 3.5 times the distance of the Sun to planet Earth, so this is obviously kind of accelerated in terms of time. Now each of these objects is slightly different though. We have the slightly larger and slightly more massive Luhman 16A, and then we have its partner, slightly smaller and slightly less massive Luhman 16B. The first object is about 33 masses of Jupiter, the second object is roughly around 28 masses of Jupiter. But both of them for the most part have, well, I would say relatively similar size, however they do have very different appearance. So the smaller object, 16B here, this is kind of what we were able to recreate using the amount of light that was received from this object, mostly infrared light, but essentially it does have unusual, large, patchy, dark areas, which we think represent clouds. Basically here there seems to be quite a lot of atmospheric activities, a lot of clouds, a lot of different possible storms, possibly somewhat similar to what Jupiter has with its so-called Great Red Spot. So this is maybe what's happening here, although we're still not entirely sure. However, its partner, Luhman 16A, has not been observed to possess similar luminosity differences, suggesting that maybe it doesn't have similar unusual conditions, similar atmospheric storms or whatever is causing these observations. And on top of that, we've never actually seen any kind of X-ray or radio signals coming from these two objects, suggesting that, well, pretty much all brown dwarfs are kind of unique and possibly need to be classified even further. Now, in terms of the actual temperature, for example, these objects are actually kind of hot. The surface temperature here, just like right here where we are, is around 1000 degrees Celsius, or about 1900 degrees Fahrenheit. And since both objects are relatively similar in mass, they probably possess very similar temperature. So the fact that they do seem to have different conditions on the surface is a little bit mysterious. Also, compared to all of the other stars that are near us, these two are actually kind of young, I mean, in comparison. They are only about 600 to maybe 800 million years old, which is about like 8 times younger than our own Sun, and also much younger than Alpha Centauri as well. But since we're not even entirely sure how brown dwarfs are created, because their actual origins are still mysterious, we're not really sure where it came from and what created it. But one thing we know about brown dwarfs is that they are actually really different. Some of them are pretty hot and they can even create their own energy using the fusion of deuterium, which is one of the isotopes of hydrogen. And some of the larger brown dwarfs can even start fusing lithium and produce even more energy. So for these two objects, we actually think that they do create some of the energy using deuterium, which is probably why they're so hot. But since these are actually the closest brown dwarfs to us at a distance of about 6.5 light years, only a little bit farther away from Proxima Centauri, it actually presents us with a very interesting opportunity to study brown dwarfs in more detail, and it's actually kind of interesting to find out more about these objects, because we've been also discovering a lot of super interesting brown dwarfs out there. And in case you were wondering why it actually took us so long to discover these two objects, one of the main reasons is actually because they're sort of located where it's very difficult to see them. They're pointed in such a way that the so-called galactic bulge that you see right there covers most of their light. So we discovered them completely by accident, and using other telescopes, a lot of other similar brown dwarfs were discovered later. But for the most part, these objects are still pretty dim, even though in this particular simulation you can kind of see them a little bit better. Here, at a distance of only a few million kilometers, they basically kind of disappear and become almost completely invisible. But now there's a new discovery coming from these two objects, and it's from this paper right here. And the discovery suggests that the first object, Luhman 16A, that we didn't really see anything special about before, does seem to possess the so-called stripes. What this means is that it's very likely somewhat similar to Jupiter in the way that it looks. In other words, it has these bands on the surface, these stripes that create various cloud covers, and one of the reasons we probably didn't see anything unusual about it before is that these particular stripes are basically not creating any patchy cloud-like formations and don't really create any storms. So in other words, it's sort of like, I guess, looking at Jupiter with the exception of not really having this great red spot. And also the other major difference is of course that this object is much hotter. Here the temperatures would basically make this object glow just a little bit. Now I was actually kind of wondering, so why is it that we've discovered it now but couldn't really see it before? And the main reason here, or the main answer, is what these scientists looked at now. Originally they were just looking at the light, and these patches were quite easily visible simply because essentially they produced a lot less infrared light compared to everything else on the planet, or on the brown dwarf. But now they decided to take a look at something a little bit different. They were looking at the polarized light. And you might know a lot about this already, but if you don't, essentially, well, light in general can be sort of twisted in different directions. This is what we refer to as polarized light, and this is how polarized glasses work. In essence, you can kind of turn the actual wavelength of light, as you can see in this particular simulation, and certain objects, certain environments can actually polarize light when it's being created or when something emits light. So for example, if you were to pass a typical ray of light through some sort of a medium that creates polarization, even things like clouds for example, what comes out on the other end is going to have different inclination, it's going to have different polarization, and this polarization can easily be measured here on Earth. This is actually how we discover, for example, the magnetism of very strong magnetars or neutron stars, because they also polarize light as it passes through certain locations. So essentially light polarization is a very well known and also quite well studied phenomenon. And by capturing the polarized infrared light coming from these two beautiful, unusual, mysterious giants, we were then able to see that, well, one of them, Luhman 16A, was actually producing a lot of polarization, but in a very specific, very unique way. As if these polarization patterns were actually formed by basically stripes. So it was kind of like striped polarized light. And this of course suggested that it's very similar to what we can see from our neighbor Jupiter. So essentially the effects produced on Jupiter are very similar to the effects produced on Luhman 16A, which of course suggests that it probably looks the same, or at least very similar. Now, so this is just the appearance of the planet. We obviously have no idea about other things in it, like for example, we still don't really exactly know what it's made out of, but theory suggests that it's probably not very different from Jupiter as well. So, in other words, the Luhman 16A seems to be a planet with stripes, or at least most of the stripes, whereas Luhman 16B seems to be the one with most great spots or great storms. They both have somewhat strange and kind of different weather effects, and this is something that I think scientists would really like to understand. The objects are very similar to each other, they're only slightly different in mass. So what causes these differences in terms of weather conditions is something that scientists would love to understand. And one of the comparisons that I've heard someone make is that it's kind of similar to how the weather or the climatic conditions on Venus and Earth are also different. So the differences here, even though the two planets are kind of the same, through minor changes over time create these absolutely different conditions on the surface, and basically, well, one of them has life and allowed the life to evolve for billions of years, the other one becomes this really hot hellish, inhospitable place that nothing can survive on. So the differences between Luhman 16A and B could be just as dramatic. And on top of that, the analysis so far suggests that there's probably, due to the temperatures, also some really insane weather conditions, like for example liquid silicate rain, basically rock. It could be raining rock here, which would probably not make this a very nice place to visit. So visiting this object is most likely out of the question, but visiting nearby locations and studying brown dwarfs is definitely something we want to do. But unfortunately, that's really the only discovery so far about these two unusual objects. But then again, we've only found them roughly around 7 years ago from when I'm making this video, so there's still a lot to study and understand about them. And once the beautiful James Webb Telescope becomes operational, I'm sure we'll be able to learn so much more about them. But we're also going to talk about other very interesting discoveries about brown dwarfs in some of the future videos, so make sure to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something you may have not known before. Also, maybe support this channel on Patreon, it does help me quite a lot. And alternatively, you can also support this channel by buying the Wonderful Person t-shirt that you can also find in the description below. Anyway, I'll see you tomorrow, space out, and as always, bye bye.